Manifold absolute pressure, or MAP sensors, are used by the Engine Control Module, or ECM, to determine engine load. In this video, we will look at P0107 MAP sensor signal voltage low. The information, graphics and diagrams in this video are typical of most systems. Make sure you have the correct information for your vehicle. I've broken up the tests into 3 sections: opens, shorts and high resistance. Each test shown will be a separate procedure. Here is a typical schematic for a MAP sensor. There is a 5-volt reference, a low reference and a signal return going to a pull-up circuit within the engine control module. Some systems use a pull-down circuit for signal monitoring. As the manifold pressure changes, the signal back to the ECM also changes. This change may be a varying voltage or a varying frequency. The amount of change will reflect the manifold pressure. The fault table indicates that a P0107 could be caused by a short to ground or high resistance on the 5-volt reference circuit, or a short to ground on the signal circuit. Okay, let's start our diagnosis of P0107 MAP sensor signal voltage low. When diagnosing any DTC, it is a good idea to check the freeze frame data to see under what conditions the fault occurred. Observe the scan tool, MAP sensor and barometric pressure data if available, with the ignition on and the engine off. Compare the readings to an altitude versus barometric pressure table for your vehicle. The data should match. Start the engine and check the scan tool data. It is best to use a graph mode if available. An oscilloscope can also be used for this. Look for anything unusual in the pattern while operating the engine through a variety of RPM ranges. A typical MAP sensor signal should vary between 0.5 and 4.5 volts. It is essential that these tests and procedures be performed before proceeding to the electrical system, as concerns in these areas may cause a MAP sensor code. Check the integrity of the air induction system by inspecting for any damaged components, loose, improperly installed or routed vacuum hoses, any vacuum leaks or intake restrictions, and a missing or damaged MAP sensor seal. Ensure that the engine is mechanically sound. A compression test may be used to confirm this. Check the exhaust for any restrictions or damage. Start the diagnosis by turning the ignition off, confirming correct battery voltage, and disconnecting the MAP sensor. Connect the multimeter between the 5-volt reference terminal on the wiring harness side of the circuit and ground. The correct voltage should be between 4.8 and 5.2 volts. If significantly less than 4.8 volts, there may be a high resistance in the circuit, the control module, or the module connector. To test for resistance within this circuit, move the meter lead from the sensor terminal to the next connector in line. In this case, it will be the engine control module. Back probe the connector and retest. If the voltage is now correct, then there is excessive resistance between the 2 connectors. If the reading is still low, turn off the ignition, disconnect the module, and check the suspect terminal for corrosion and terminal tension. If all appears okay, then there is excessive resistance within the ECM. With the MAP sensor disconnected, the ignition on and the meter connected between the 5-volt reference and ground, a multimeter reading of 0 volts indicates an open or short to ground. To determine whether the fault is an open circuit or short to ground, simply move the meter lead from battery negative to battery positive. If there is now battery voltage, then you have a short to ground in the harness, connector or ECM. If the voltage remains at 0, there is an open in the circuit. Turn the ignition off and disconnect the ECM. If the multimeter still reads battery voltage, there will be a short to ground in the harness. Carry out a continuity check between the sensor connector 5-volt reference terminal and any other terminal in the ECM connector. If any reading other than infinite is displayed, then there is a short in that circuit. If no fault can be found, then the short to ground is in the ECM. To test for an open circuit, move the test lead to the next connector in line. In this case, it is the ECM. Backprobe the correct terminal and retest. If there is now battery voltage, then you have a short to ground in the harness, connector or ECM. If the reading remains at 0 volts, then turn off the ignition, disconnect the ECM and check the suspect terminal for corrosion and terminal tension. If everything is okay here, then there will be an open circuit within the control module. With the ignition on, connect the meter between the sensor harness connector signal terminal and ground. If the meter displays 0 volts, then there is a short to ground in the signal circuit or within the ECM itself. With the ignition off, the sensor and ECM disconnected, check for a ground on the signal wire by connecting the meter between the sensor signal terminal and battery positive. A reading of 12 volts will indicate that there is a short to ground in the harness. If 12 volts is not there, this indicates a short to ground in the ECM or a short to another circuit coming from the ECM. To eliminate this or confirm a short to another circuit, set the meter to ohms and check for continuity between the sensor signal terminal and all other terminals in the ECM connector. If all circuits and connectors are confirmed as OK, then replace the map sensor. That's how to diagnose P0107. Understanding the procedure before commencing work ensures a correct, professional and cost-effective repair. Remember, diagnose, don't guess. Thanks for watching. Bye for now.